Okay, with our focus on normal distributions, let's look at some characteristics that you might see with normal distributions. When you draw a normal distribution, we've talked about the mean being in the middle. It resembles a normal bell curve. And a lot of times you will see a line coming down from that peak in the middle, and that's where we draw the mean. The units used on the x-axis are usually in standard deviations. So we have 1 standard deviation, 2 standard deviations, 3 standard deviations away. When you go to the right, those are positive numbers. When we go to the left, we would be using negative numbers. And when we're dealing with normal distributions, we don't usually use units beyond positive and negative 3 deviations away, because most of our data is going to be within 3 deviations. Usually it's going to be an outlier if it is beyond those 3 deviations. Now our shapes can vary depending on the size of our standard deviations. If we had a very small deviations, our graph might be tall and narrow. If our deviations are large, then that usually widens our graph out. So these are small standard deviations, where these are larger standard deviations, and it changes the shape of our normal distribution according to the size of the standard deviations. Another characteristic of normal distributions is called a point of inflection. And there's one on each side, and it occurs at the point of 1 standard deviation and a point of inflection is when your graph changes from being concave up to concave down. So it's curving up here, and then it's changing to being curved down, and that point is called the point of inflection. So it's curved down, and then as it hits here, it changes to start curving up again, and so that is a point of inflection that occurs in a graph. But that curve has that point at 1 standard deviation away from the mean. So that's what that point of inflection means. That's just kind of a little tidbit. You get into more advanced math, you'll talk more about that point of inflection. That's really all I'm going to say about it as far as we are concerned, just the fact that you know that it is there. Another fact about normal distributions is that no matter where it is on your number line, if we started at 0 and had our normal distribution, if the same graph shifted and it had a different mean at a different location, but the standard deviation was the same amount, the graph is going to look the same size, but it's just shifted along the graph. So that's another thing to think about in terms of normal distributions. They're going to look the same, but they can shift along that number line graph based on where the mean is and how much the standard deviation is. It shifts. So the graph changes according to the size of the standard deviation, and it shifts according to the value of the mean. So according to the size of the deviation, it changes the size. According to the value of the mean, it shifts along the horizontal axis. So the mean value can shift it, and the standard deviation value changes the size. One of the other interesting things about normal distributions that sometimes gets confusing to a lot of people is that it is known by many names. So we call it the normal distribution curve. But you'll also see it referred to as a normal density curve. You'll also hear it referred to as the area under the curve. You will also hear it referred to as a probability curve. A proportional curve. So these are things that you will also hear it referred to. This is the most common name that you will hear, is that normal distribution curve. But do keep in mind that these other names will also be used to refer to it, and it does mean the same kind of value. It doesn't change what you're looking for, it just changes how they ask the question about it. Now let's look at a type of problem that we might have. If we had a problem, let's say we had a person named Rudy who scored an 80 on a history test. And that history test in the class had a mean of a 60 on that test, and it had a standard deviation of a 20. And we wanted to know how Rudy compared to the class. So what we would do is we would sketch our normal distribution. And so here at the mean, we would put in our value of 60. At one deviation above, 60 plus 20 gives us a value of 80. At two deviations above, that would be 100. And at three deviations above, 100 plus 20 more would be 120. Now, going in the negative direction, we would subtract the 20. So this value would be 40, and then 20, and then 0. Again, we don't need to go more than 3 deviations above or below. And so this is the mean for the class. Rudy's score is at 80. So here's Rudy on the scale. So how could we say Rudy's score was in comparison to the class? So Rudy's score was 1 standard deviation above the mean. And so that is using the normal distribution to look at how Rudy compared to the rest of the class. And it does look like Rudy was in the top portion of the class. Which leads us to one of our next topics, we're going to be talking about the empirical rule, and we will give a percentage for how Rudy actually compared to other people in the class, compared to his score and the other people in the class. And so that is going to be our next topic.